Hello and welcome to some helpful hints on the practice test for chapter number 7. This is working with systems of equations and inequalities. The problem we're working on right now is a system of equations using the elimination method. And the elimination method, we need to have all things lined up. So here I've got the x's aligned, the y's aligned, and the equal signs are aligned. So that is in good form. From here we're going to make sure we recognize the idea with elimination is once they're arranged with the x's, y's, and equal signs all over top one another, then we can go ahead and find additive opposites. So the point of elimination is to find an additive opposite. So we're taking a look at those coefficients. So here I have a coefficient of x of 2 and here 3. To make those additive opposites, I would need to multiply both equations, which is possible, but a little more work if it's not needed. Here I have an invisible 1 and a negative 3. To make those additive opposites, there's a little less work involved, so we're going to use and try and eliminate the y's to start with. In this case, I can multiply by 3 and find that 6x plus 3y is equal to 15 as my new equation. I can transfer over the bottom equation and recognize that now I have a situation with additive opposites. So the positive 3y and the negative 3y cancel. This is now going to leave me with 9x is equal to 18, which then tells me that x is equal to 2. Using this, I can choose either the top equation or the bottom equation to plug x equal to 2 into. So I'm going to go ahead and maybe start off with the top equation and have 2x plus y equals a 5. And where I see the x, I'm going to plug a 2 in because of this over here. We found that to be true. And that's going to give me 4 plus y is equal to 5, leaving me with y equal to 1. Now I'm going to check my solution, and I have to do that in the other equation. So if I started with the top equation, I'm now going to be working with the bottom equation. So the check has to be done with the other equation, and I'm going to check 2, 1 into the bottom equation. So that's the equation that says 3x minus 3y is equal to 3. So where I see the x, I'm going to place a 2, and where I see the y, I'm going to place a 1. Three times 2 minus 3 times 1 equals 3. 3 times 2 is 6, minus 3, in fact, does equal 3. It's nice to know that this does check out, so we are going to write the sentence for the equation. So our solution that we found is 2, 1. Excellent, because if we were to graph these two lines, we would find that these two lines intersect at the point 2, 1. Excellent. We're going to take a look at number 14, as some of you were not available to be in class and check this out. So if we didn't go over this in class, number 14 is where we are headed next. So number 14 is also an elimination problem, and it has to do with two equations, where the first equation is 6x plus 3y equals 6, and the second equation is 8x plus 5y is equal to 12. Now again, using the elimination method, we're looking to make sure that we don't have to rearrange. So the x's are on top, that's good, so are the y's, and the equal sign. This tells me that I don't have to rearrange any of these to make them eligible to be eliminated. Now I'm going to take a look at the coefficients because I want to find coefficients that are additive opposites. And the coefficient of 6 and 8, there isn't an easy multiple, but we can actually absolutely make that happen if necessary. They're both positive, so it's telling me I need to multiply one of the equations, and only one of them, by a negative. I can also look at the y's to see if that's easier. I've got a 3 and a 5. And those are smaller numbers, so perhaps I'll work to eliminate the y's first, just based on the fact that they're smaller numbers. I also take a look to see if perhaps I can divide something and make it a little easier for myself. So if I take a look at this, I notice that all of the coefficients, the 6, 3, and 6, can be divided by 3. It's possible that you could notice this and divide this entire equation by 3, which is the same thing as multiplying by 1/3. In doing this, I can recognize then that this gives me 2x plus y is equal to 2. And I have a much smaller equation to work with. Now from there, I can take a look at my next equation of 8x plus 5y equals 12 and see if there's an easy way to work through that. Now in doing this, I sort of made this a little bit harder in the case that I can't divide 8, 5, and 2. There's no common factor amongst those. So if I was to take a look at this, I can keep this the same, but I still have to do another type of multiplication because I don't have an additive opposite. So if I had 8x plus 5y is equal to 12, again, I'm still looking for those additive opposite sections, so those are not yet additive opposites. Neither are those, and neither are those. However, I can multiply again and make that occur. So perhaps I want to multiply this equation here by, let's see, we eliminated the y's last time. We can eliminate the x's by multiplying by the number of -4. So let me kind of give myself a little bit of extra space. One moment. So I just shifted that over to give myself a little extra space. Now I want to get this and multiply it by 4, but it needs to be a negative in order to make a -8 and a +8, because this here is a +8. So that then gives me this concept of -8x minus 4y is equal to -8. And pulling this over, I get 8x plus 5y is equal to 12. Now I find that I do in fact have additive opposites here with the x terms. Since those are additive opposites, they